When the base current is equal to 0, the collector current is supposed to be equal to 0 too. However, there's a very small leakage current flowing from the collector to the emitter actually. That is the ICEO. It is less than a few tenths of nanoamperes. This figure magnifies the magnitude of this leakage current for clear illustration purpose. Putting the figure back to the actual scale, it will appear like this. When the base current is equal to 0, the collector current is also equal to 0. In the active region, the collector current increases slightly when VCE increases. However, in the theoretical calculations, we often ignore this small increment and assume that the collector current is independent of VCE. Therefore, this portion of IV curve is simplified to be some horizontal lines. This x-axis shows a voltage range of 0 volt to 5 volts. With such a small voltage range, we may see the details of the IV curve in the saturation region. However, the collector to emitter breakdown voltage of a small general-purpose transistor is usually higher than 30 volts. Therefore, the voltage range of VCE should be practically much larger. In this figure, the x-axis shows VCE ranges from 0 volt to 25 volts. With this large voltage range, the IV curves in the saturation region appear to be a straight line, because the VCE of the saturation region must be smaller than 0.3 volt. That is very small compared to 25 volts. In our discussions, we assume that VCE saturation is equal to either 0.2 volt or 0.3 volt, regardless of the position of the saturated Q point. Because of this assumption, this must be a vertical line. Let's discuss the reasons for that now. This is a low light. This Q point is in the saturation region. We can see that VCE saturation is equal to 0.2 volt or 0.3 volt. In Part 1, we have discussed that the y-intercept of the low light is equal to VCC over RC. Therefore, larger the RC, lower the y-intercept. Now, this is another low line with a larger RC. Its Q point is here, but VCE saturation of this Q point is less than 0.2 volt or 0.3 volt. So VCE saturation is in fact not a constant. However, if we assume that VCE saturation is a constant and is equal to 0.2 volt for all Q points in this saturation region, then each IV curve in the saturation region must be a vertical line above the 0.2 volt. Let's have a summary of what we have discussed so far. On the left-hand side, we have an IV figure which shows the details of the saturation region and the cutoff region. On the right-hand side, we have another simplified IV figure which will be used for explaining the theoretical calculations.